Alright, today we're doing 1.6. We're going to talk about how to do inverses. Inverses are operations or functions that undo each other. Like addition is the inverse of subtraction, they undo one another, and multiplication is the inverse of division. So if you had f of x equals x plus 3, then the inverse would be x minus 3. You have to undo what was there before. And to multiply by 2, then it would be dividing by 2, which is the same as 1/2 x. Notation-wise, we write an inverse with a little negative 1, either on the y or on the f of x. If we wanted to graph an inverse, we'll first start by graphing x cubed, which looks like that. In order to undo a cubed, we would have to cube root, and a cube root looks like this. All inverses reflect over this line. So when you have 1/2 of the graph, you're just going to reflect it over to create the inverse. How do you know if an inverse exists? You can do the horizontal line test to determine. Not all functions have inverses, but for a function to have an inverse, it must be 1-to-1. Which means that there are no repeated x's or y values. So vertical line tells us if it is a function. Horizontal line tells us if it is 1-to-1, which is the same thing as determining if it has an inverse. So we'll graph our parabola, something we're very familiar with. And now find the inverse and graph it. So the inverse would be plus or minus square root of x, because you need both halves. This does not have an inverse. If I draw a vertical line right now, this is not a function. And since it is not a function, it does not exist as an inverse. If we went back here and used the horizontal line test, we would see that it hits twice, and so it does not have an inverse. So I can have a function, a perfectly legal function, but there are many functions that do not have inverses. X squared is just one of them. On the back side, we have a couple more pictures of inverse or of graphs, and you're determining if these are inverses. So first, I'm just using a vertical line to verify that they are functions, and this one is. This is the absolute value. But as soon as I do horizontal line test and it hits twice, there is no inverse. Cubed, we already did this one on the other side, but just to reiterate, if you draw a vertical line, we're okay for function, and if I draw a horizontal line, there is nowhere where it touches twice, so this has an inverse. Passes the vertical or horizontal line test. And this one fails the horizontal line test. You can also find the equation for the inverse by using algebra, so you don't always have to graph functions. So in order to do that, we're first going to replace f of x with y. We're going to switch places, the y and the x. So just switch where they are. Don't take any of the numbers with, just switch their places. And then we're going to finish by solving for y. The first thing we do here in order to get rid of a cubed root is we would cube. And that gets rid of the cubed root. Then we're going to add 5. This is the inverse. Make sure you use that notation so everyone knows that this is now the inverse of the function, not the original. With 3 more below, try to find the inverse of each. First one, I'll replace f of x with y. Then I'll switch them. Then in order to get this out of the denominator, we actually are going to multiply by it on both sides. So then it cancels. Then I'm going to divide by the x. And then I'm going to add 2. And that's the inverse. Here we've got the y equals the cubed root of x plus 1 over 2. I'm going to switch places. The first thing we're going to do is cube. That undoes a cubed root. We're going to multiply both sides by 2 to get rid of the fraction. And then we're going to subtract 1. And that is our inverse. Last one, I'm going to switch the x and the y. I'm going to multiply both sides by 2. I'm going to minus the 5. And then divide by negative 3. And that is inverses.